also the DVR, the exercise lab in the classroom. I think that may be not enough, but that may be the starting point for the project. So while you are doing your project, please contact the GA or me if we have any more doubts. Because we have a lot of things to do, but it's already November, so I'm going to going on the next chapter. Okay. So this is the screenshot of the, I think the 4 or 5 years back, the database project in this class. So the project title is why not developing the relational database management system. So this is one of them. So you can see it's named the UBDB. So create the database, and we can create the database. Then using database, it's similar as the MySQL standard. It's based on the SQL 2 standard. So and create the table. In one semester, student did. We had 2 teams at the time. This is the better one. And I have to create the table. It supports only 2 data types at the time, integer and string. Number or the character. And as you can see, this is pretty much the very basic SQL standard. Definitely it checks the syntax of the SQL. And insert other value, and then finally select. So it was really tough because we did a semester to develop this one. At the time we used the C++, and pretty much we implement a very basic thing. But after this class is closely listed with the undergraduate, I couldn't do this one because I need to cover the database design part. Then truncate is the syntax to delete all the data without schema. Then finally we can drop the table, and there is no student table over here. So before we start, the next chapter is for the data file and the index file. I'm going to make the 2 groups, and I think that you can join the student, the 3 one group and 4 one group. I will give the 5 minutes to talk about if each team is asked to develop such a database management system, especially relational database management system. So what component, very high level, what component, what module do you need? Okay, the brainstorming. So one example is we need to compile to interpret the SQL language, SQL standard. For example, so compiler or interpreter for SQL. So find the module that can be the high-level design of your relational database management system. Okay, it's a very high level. Doesn't have to be very detailed. It doesn't have to be very detailed. Very high level, like we need the SQL interpreter, like that. That's one example. And what else do we need? So why don't you make a group by 4, and you can join this group. I will give you the 5 minutes. And one of your member will quickly grade. What component do you need? So, right. It's a very high limit. It doesn't have to be very limited. Can you guys brainstorm like this position? So, a couple of you can come over here. It's a 5 minute. Quickly, just list them. You don't have to debate. Okay. What component based on the idea and the design was something we have learned so far? If you are asked to develop the database management system like the MySQL or Oracle, what component do you need? You don't have to search the internet, just you're the brainstorming. It's not designing problem, it's the designing of software, okay, DBMS software. Suppose that you are developed Oracle.
Choose a host language. Your interpreter depends on which language you choose. Like Python uses Django, but Django doesn't work with C++ or Java.
Everything is done?
That's it, high level.
What if I assigned another project next week? So think about just it's brainstorming. Doesn't have to be correct.
Before you get into what you want in the database, so you need to choose a database. Focus
1 minute?
So you need to choose what database tool you're using, whether it's AWS or GCP or something else. You also need to choose a host language for your program. So Java, Python, web applications, all that. And then you also need to choose an interpreter based on the host language and the DB you're using. I think that's it. And everything else you can start getting into the nitty-gritty of the specifics.
Why don't you wrap up the 10 second? Who's gonna brief your brainstorming wizard? Okay, time's up. How do I start? everything. So first group A. So please give me your DBMS. Group A DBMS, the Highlander design. What do you need?
A data?
Data. Do we need the data to develop the DBMS? DBMS is the software. Like think about you develop the Excel file. Do I need the data first? Right? So we are going to develop the software, not the databases, the design. So I don't think we need the data, user data here. Right? So anyway, data.
Then database compiler?
Compiler.
Yeah.
Okay. So that is like the interpreter, SQL interpreter.
Yeah.
And what else?
Web application front-end?
Web application. And what else?
GCP cloud?
GCP cloud.
Any cloud name? Administrator?
Administrator. Okay, that's good. And B,
So you said that you need to choose a host language,
host language.
and then you need
Host
to,
language means what?
C++, whether you're using C++.
So to develop this system, okay?
Yeah, you need to choose a host language, and then you need to choose a database host, whether it's GCP or AWS. So the system for the database, and then you need to choose the interpreter for the language that fits the,
Interpreter.
yeah, that fits the, between the two.
And what else? You guys discuss a lot.
That's what we came up with.
So I realized the similar problem nowadays. The more and more software, and one of the trend of the computer science is abstraction. The one of the example is the program language, the object-oriented programming. There are different ways of defining what is object-oriented programming, but it is true. The reason why we are using more and more the object-oriented programming is because the software design is getting more complex, and there are a bunch of different libraries. So it's abstraction. Okay, we'd like to hide much more very detailed or complicated part. The behind we don't have to know. Instead, we can focus on the module by module or the design by design, and so on. Simplify the problem. Because of that, so you can see from the many universities, including UB, the curriculum at the computer science has been changed a lot the last few years. The main change is from the system level, the course like the operating system, computer architecture, computer organization, the network. It's not core courses. Instead, we need definitely algorithm and program language, and sometimes we don't have such a thing. That's true. Why? We need to get a job. Nobody wants to system developer, system design. Okay. That doesn't mean, even though there are services like the serverless, do you think really no server? Doesn't make sense. Without computer, we cannot run any program. So behind is abstraction. Because of that, the company need the new employee who knows the programming. At least the design, the software part. But what about the database system? Is it application level or the system level? It's kind of in between. So I realized that I understand such a trend, but that doesn't mean that you can ignore the system part. So database, if you are asked to design the database management system, is kind of a software development like the Excel. Okay. So far we have focused on the database design to keep how to manage the user data organization. Then to create the database, we need such a DBMS. So second part of the semester, we'd like to focus on how the DBMS, like the Oracle, Informix, DB2, MySQL, is the database software are organized, designed. So for example, if you are asked to develop such the DBMS system, for example, what about the host language? Host language is the developing tool, not such a DBMS. To develop the DBMS, so for example, the Oracle, most of the system they are using the 70-80% of the C or C++ language, and 20-30% they are using the assembly language. And nowadays there are DBMS which are based on the high-level language like the Java and so on, but it's not main component of the system, right? So I think there's something misunderstood. It's because we never thought about the system level design and the Unix, the programming and the administrator part. So I gave the example of this one. For example, if you develop the DBMS, like let's say the UBDB, the relation, we are going to sell this one. We are going to develop this software to create the database that you design. To do that, first, this guy should understand the SQL language because SQL is the standard of the relational database model. Okay? It consists of the data manipulation language, data definition language, and so on. They should have the SQL interpreter. Right? And also, what about the create table? What happened? Think about when you submit the create table. What happened? Table should be created. Then, if you remember pre-schema architecture, we have an external view, and we have conceptual level view, we have internal level view. So this guy focuses on internal schema, internal data structure. Okay? If you remind what we have discussed for this one, the internal level view, who is in charge of that? DBMS. Okay, then that means when you submit the SQL to create the table, what happened inside? First, interpret. Right? It's compiled. Then, create the table. Where? How? How can the UBDB create the table? In other words, what will be the data structure when you create the table? Inside. Here. How do you store the table? Where?
Memory allocation.
Manual location?
Memory.
Memory? What if turn off your computer? That's the programming level. Okay?
So is it on the server?
That is what? You can use a file. Okay? For example, if you create the table employee, blah, 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 blah. Employee file can be created. Right? So there is one file, employee. Then, if you have the more details, like the column name, this one may have inside, not like this. This one may have the ID, name, and this one. It's data structure, right? Where do you keep such a data structure? Hard drive in the relational database model. We are implementing relational database model. Okay? It's a catalog database, right? Do you remember? When it's a catalog database, it's all metadata. That is one of the different from the without using the DBMS. So we need to design the catalog database, like the information underscore schema on the MySQL like that. So still, this is one way you can use a file. Sometimes I don't want to use it. What is a file? File is the object inside database. You have file without database on your laptop. File is file system. if you take the operating system, the file system is what? Software to manage files, bunch of files. That's the NTFS or ext1, ext2, 3, 4, 8, and so on. This is a file system. So you can use the file system to create your database as a file for each table. Or I don't want to use the file system. Any other way? You can directly write your file. How this one? HDA, HDB. Okay? Under DB. It's a raw device. You can use the raw device. So first thing is you need to design, make the data structure for data file. Data. Also, later we will discuss about to speed up to access the data, we have index. So index file structure. Whether we are going to use a file, system file on the file system or such a raw device and so on. Similarly, what else? I mentioned several times optimization. When after we translate into the something, whatever the inside the language is, we need to find the fastest. That is the main reason of this DBMS. So we are going to create the query, first processing, then query optimizer. Then this one can access this guy. Anything else? It's just the start. If you take the operating system also, I think the chapter 5 or 6, so one of the main problems of using such an operating system is operating system allow how many users? Many users, right? And inside, even though you allow the only one client inside the kernel, how many processes? Many processes. That causes the problem of what? Race condition. Okay, synchronization issue. Same thing for this guy. Database also support many users, many different views, many users. So how can we need to address such a thing? We need to manage the transaction management. Also, still the main reason is to access the data very fast. So because we need the query optimization, we need to index. And also, that's not enough. So somebody mentioned about the memory. So definitely we need to use the memory as a cache. That is the way of surviving the computer science. Computer use a lot of every time cache, because if you access the data directly, the original media, you would, no matter what the hardware you use, media use, so you cannot actually address as just speed problem. We need to use the cache. So data recovery. Yes, that's another thing before that. So we need to manage the memory. It's called the buffer management. Buffer management is the same name as cache management. So database use a lot of such a memory. And also, definitely, it's not safe, so we need to back up and recovery. Also, anything else? We need to support client to access this one. So like as you learned in network class, we can support like do the TCP/IP. So it's the server management. So there are the server program that allow the client process to access this data. Like if you remember how to access the MySQL, --host, then give the IP address, then username and password, like that. So server management. And also, authentication is also important. Security module. We need the security, like that. There are a bunch of the components are needed. So, but somebody may complain. Do I have to know this one? But eventually, we are using computer for what? Access the data very fast. So sometimes you can address such a problem through the software algorithm using the programming level. Not enough. So definitely we need to address the problem through such a system programming. Eventually hardware also. That is the reason the Google or AWS, they try to hide this one. They are going to be in charge of this. However, still they are using such a system. So if your query is slow, it's very hard nowadays to address such a problem. Instead, they are suggesting, why don't you purchase the better or higher, it's more expensive, the server, virtual machine, because it's cloud-based. Okay? So GCP and AWS is a computing environment. It doesn't mean it's part of this component. This database management system running on there. Okay. Then from now on, so far we have learned how to design our data. Okay. So we are able to create the table or insert the data. So using the DBMS, but we do better know more about the DBMS software. So today we are going to start such how data and index file structure are organized, and also we will see query optimization, query processing, and we will see some part of the transaction management and also concurrency control. So concurrency control is important. Think about you transfer your money, but your friend, your parents, does not receive any money. So who will be in charge? So we need to be transparent for such a transaction and so on. So, but not much the buffer and the backup and recovery. If we have a time, we will cover it a little bit about that. And we will talk about such a main component of the DBMS system from now on. This will not be easy without understanding the basic concept of basic knowledge of computer science, like the operating system and the computer architecture and the network. So this is a good time. So if you do not know such a thing, so it's to catch up. After I delete the iCloud service, so something messed up. So some of the file deleted. And also I upgrade to the Catalina new version of macOS. So we are going to, in this chapter and the next chapter, we will see how DBMS store the data in their system and also index the table and the indexing structure. But if you understand I think if you already took the operating system class, so last part of the operating system is the file system, and the file structure, file system is very close there. So let me ask the question again. you have seen the same query from the UBDB, the screenshot. So if you are asked again, so how to, this one is also the very interesting. So compiler. UB does not have the compiler class, but if you have a chance to take the other online class or the, I'd like to offer the compiler class, but not the right now. But the SQL is also a compiler. It's a very, I think that is a kind of really compiler of the old computer science knowledge in the compiler class. So it's worthwhile. But so through such a compiler interpreter, this one was processed. So your DBMS should create a table for employee. So there are two options to create the fine. So first one, using, how do you create the table? SQL. So you are using SQL. So from the DBMS point of view, so how do you create inside, internally, your table? Using file system. Another way is without file system. So without file system, how do you store the data? You can directly write the raw device. Okay, if you run each operating system provide the 200 to 300 system code. Okay, system library. So Unix library or Linux library. So all program languages use such a system library. Then plus the program language library, then you can code. So among the system library, most of operating system code, system library provide how to write the data, how to read the data. Okay, you can directly write the data to the SSD or hard disk drive. So from the operating system point of view, it's viewed as the DV, HD, A1, 2, like that. And using offset, you can write the data directly without using file, without using the file system. So there are two options here. Most of the DBMS system, Oracle Informatics, anything, they support both of them. So which one may be easier? Using file system. And which one will be faster?
SSD wrong.
Yeah, so both of them can use the SSD or the hard disk drive. But I mean the file system, the raw device, which one will be faster? Raw device is definitely fast. Why? Yes, the file system is, think about let's say that we are going to use a hard disk drive. Hard disk drive is like this white sector and the cylinder number. So you need to specify, so each one has the block, logical block address, 0, 1, 2, 3. Then there is a what? Controller. Disk controller, for example. And controller is communicating with your computer. Okay? So during if there is an interrupt, then the request, your CPU, using the read or write the system code and write the data, ask where. So something, the address, like the integer I is a high level address and it will be converted to the low level address. Okay? So eventually logical block address. So this integer A will be written to here. Okay? How about the file system? If you are using file system, so file system is a software you need to purchase, you need to pay. Most of them are included as a bundle of the operating system, but you need to pay actually. Somebody developed that software, like your program. So using the file system, so you don't have to worry about the specific location, very low. So like if you are saying the longitude, 43, blah, blah, and the latitude, and 60. Can you find the location? It's very hard. Nobody remembers. You need. However, if you have the logical address, Bridgeport, and Main Street, and at 100 Main Street, Bridgeport, you can find that. Okay, because it's a high level, the address. Same thing. So file system actually manages such in between the low level and the programming level. So from your programming, so you can just use API for the file, like the create the file. Like in case of Java, Java has a file stream. So you can use a file stream to create a file or read the file. However, you need to go through the several steps. Right? It takes a longer time. It's because it's module by module. You need to communicate and each module. It takes a time. Instead, if you are using raw device, directly ask the disk. You are the disk controller, and this controller know the logical block address, and this one is moving and write the data and read the data and come back to your computer system. So you need to decide which one you are going to use. Most of commercial DBMS, you can select the option. You can select the option how to create your data structure, database, using either file system or raw device. So we are going to focus on the file system. Okay? So raw device is faster, but it's not intuitively understand. It's not straightforward. The file system. What is a file system?
Software.
It's a software that includes the two main parts: files and directory. So directory is a data structure for what? Because too many files. How many files do you have? First of all, on your laptop, how many files? Many. Nobody knows where are they unless you have software. Okay? And also your file system has what? Actually not tree structure. Eventually it's a cyclic graph structure, but like this graph structure. This one is called directory. Directory does not have, it's not the file itself, it has a number of files inside. Also directory may have another subdirectory. So because of this one, we are able to access the file. We are going to make the file. So instead of using. However, NoSQL database nowadays, for example, HDFS and HBase, they are using directory as a data structure for the table. Under the directory, like the employee directory, you can, it's a lot of file. All file considered part of the employee. It's used in the big data system. But most of the DBMS, relational database management system, using file. So finally, we understand what is a file, then we can use the file. Okay. However, if you have too many tables, like too many files in your database system, like the 2,000, 3,000 the table, which means 2,000, 3,000 files. So it's messed up. So most of commercial database management system create the table space or database. So MySQL use the name of database. Like you need to create the database, like the company database. So all table belongs to the company. It will be created inside. Logically, it's not physical location. Physical location. This part can be this hard disk drive. This part can be the SSD, like that. Okay, it's an internal level, low level. So your DBMS should manage this one. When user create such a space, it can be database. Oracle use a table space, but they are the same concept. Okay, so it looks like the file system. Then after we create such a space, we are able to create the file. Anyone who used the AWS S3 or the Google storage, the GCP and AWS, and especially AWS, they have different the service for the storage. Okay, most of them nowadays support object-based storage. Object-based storage, for example, S3 on the AWS or the Google storage on the GCP. They are called object-based storage. Object-based storage means what is the basic item? What will be the very basic unit of your the storage? It's an object. File is set. Okay. However, operating system, what file system are you using? NTFS or ext something number? Unix file system. These file systems are based on when you create a file on using this file system, what happens? They are using number of blocks. It's a block based. So what is the block size? Operating system use usually 512 bytes. One multiplication of this one, because OS use this size of the data as the input and output unit. Whenever they read the data, 512 bytes, which is called the OS block. So file system use the same mechanism. When you create the employee file or the lead.txt file, any file, they allocate, file system allocate number of blocks from the low device. Such a low device. That will be the logical block address. So this block doesn't have to be contiguous. Okay? But if you are taking operating system, the file operating system class, the file system chapter, you will discuss about how to allocate the block. Indexed block, contiguous block, extended block, and so on. You can use DBMS should use the same mechanism. Allocate the block to create the file. Same thing. When you create the table, so number of block will be allocated inside this table space. So you don't have to create the file structure for each table. Instead, you can create the one. So sometimes you can see the component .dbf file from operating system. This size is 1 gigabyte. This is a space. Inside this 1 gigabyte of file, inside you can create a table, you can create the one. Index, so on. So this one is divided by the number of blocks. Each block is multiplication of that. So that is called database block. Okay? So it's like this one. Logical block. Logical block is a really low level. When you purchase the hard disk drive, so before you format, it has the low level, such a block. So have you ever heard about the factory reset of your hard disk drive or SSD? So for example, so I have a new girlfriend. So but I took a lot of photos with my ex-girlfriend. So I tried to delete. What happens when you delete the old photo?
The pointer, but not the actual file.
Actual file is there. So I format, even still there. Okay? So until you erase such a logical, you cannot erase this information until you are using the software provided by the manufacturer. So manufacturer provides such the low level, the formatting, the tool. So that is the logical block. And we have the OS block, it's an operating system level. Then the file system block, then the database block. So database block is the highest level, which is based on this, which means multiplication of the 512 mostly. So nowadays, 2K or 4K size of the database block. And if you are using the big data warehousing system and so on, it can be 2 megabyte, 4 megabyte. Anyone who have ever used a Hadoop system, big data system, if you are interested in the big data, so Hadoop is the most popular, the big data solution nowadays. And this one use the Hadoop distributed the file system, which is called the HDFS. This is also storage. It's not database yet. Plus, database is called the HBase. HBase uses the HDFS as like this one. At that time, HDFS used 64 megabyte, nowadays 128 megabyte block size. That means, even though you read 1 byte of data, entire 128 megabyte of block will be copied to the memory. This is another thing you need to understand. When you read the data, what happened? Each block that contains, I try to read the 8, it's a 4 byte, but entire block that include the 8, integer is a 4 byte, and return to where? Memory. CPU cannot read any data except the memory. Then, if needed, it can be cached to the L2 cache, L4 cache is not, L2 cache. Even though there are cache area inside the chip to speed up. Then finally, CPU can copy such a data to the register. This is how it works. At the time, if you are using 128 megabyte block, I need only 1 byte of data. Entire 128 byte will be copied to the memory. That is the reason when you are using the big data system, you'd better use the bigger size of memory. And also, it doesn't work very well with what? Online transaction processing. Online transaction processing need shorter or the longer response time. Which one? Shorter response time, but it will take a longer time. So this system is not good for online transaction processing, but there are software to address this one. So this is the overall thing, including operating system, file system, big data, to understand this is important to understand how the DBMS system read the data. So what you guys need to do is design the data structure of this. Very similar as a file system in operating system class. Okay? Especially if you are interested in such a big data system uses exactly same architecture as this. But it's distributed, which means one node, another node, another node. Data will be distributed along the number of nodes. Okay? So, go back to here. So finally, I'd like to create the EMP table. Then actually this one is the block. Number of block will be. So let's say that I'm going to use a 2 megabyte database block. 2 megabyte, 2 megabyte, 2 megabyte, like that. So when I create this one default, the 10 megabyte will be allocated. 5 block will be allocated. Okay? Then create the file of the EMP. So file is the data structure. Physically, data will be stored here, but there are header information header. Go back to the directory. Directory does not have a file. Instead, directory has the file information, header information of the file. So that's the reason you can search. Because you don't access the data on the file, instead the file name. Using file name, you can search. Or list. You can list up the file from the directory. It's a header information. Each system, such a space, when you create a database, when you create a table space, it will create such a data structure like the file system and the header. Then when a user creates a table, allocate the number of blocks. How can we allocate the block? unused available block. You can manage a list of available block. Right? So it's a free space management. Have you ever heard of a free space management? Operating system. The file system uses such a free space management. You can use, there are several different approaches. One, the very simple example and the most used is a bitmap. So 0, means unused, available. If used, check, change the 1. So what you're gonna do is find the first non-zero value bit. Then you can calculate. It's a 1 bit represents 2 megabyte block. You can calculate. So how can we search? There are instructions from the bitmap. So bit operation is the fastest operation in the CPU level, processor level. So we can use find such a available block and allocate, change the 1, 1, 1, 1, 1 like that. How can you manage a number of blocks for table? There are different ways. You can use linked list. Linked list, or you can use, you can allow only contiguous 5 all together. It's not it's not very high utilization. You may have some small chunk. So you can use indexed. You can create the index and the point like that. Most popular one is, so 1 block is small, but the contiguous is not convenient. So you can allocate 4 blocks as the extent, bigger size of the data structure. So the modern DBMS system use extended based, so such a file data structure. Okay. And yes, so I think that sometimes some of the DBMS like the Oracle allow such an extended size. Okay, so this is what's going on. From the operating system point of view, it's nothing but the file, but inside is a database structure. Okay? Once you set up during the design, you design the such a how, whether we are going to have the database or table space, what will be? Is it the file system file or the raw device? After you set up, then you can design what is the block size and how can we manage this one. It's very similar as a file system. That was the reason when I told you the operating system, the most important project was to develop create the file system itself. So it's you learn really a lot if you understand such a file system. So AWS provides a service like Elastic Block-Based Storage, EBS, like that. EBS is a block-based. However, object-based you don't have to worry about. The only way to access or find the data is object ID. But behind, they developed this. They provide the API for the object-based. Okay. Then, finally, we can talk about this. So let's say we have the 4 blocks and so locate the employee. Then how this employee file is organized. Okay. Simplest way is, what is the CSV? Comma, separate the file. Like Lee, comma, 111, comma, CS. A new line, James, and the 112, and the EE, like that. You can use comma separate. Comma can be used for delimiter. And the one line will be used for what? Record. Okay. Then, when we access the data, open the file and read by, tokenized by the comma, then first line by line, okay? Then the tokenized by the comma, then read the first data is the name column. Second, ID column. And the third one is the major column. How do we know? There is another catalog database. So when you create the table, all this information stored at the catalog database. So when you read the slide, so this one, you need to check the data structure of your table specific. Okay? What is the name of the table? What is the column? And what are the data type? Plus what? Where are they? Eventually, you need to access this block. Okay? Then you can return to the user through this service, query processing, and read this one, optimization, and read the data from data file, return through the user like this. This is an overview of how your query is working using through the component. So, problem is how to organize this file structure. Okay? Finally. So I already explained about the block. So most of unfortunately, the UBDB that I displayed, at that time we didn't have enough time. We couldn't use the block-based. Instead, we just create a table, either file, TXT file. Okay? Then use a comma separate, which means it's a simplified version. But the most of commercial DBMS, they are using such the block-based. So that is a block. I don't have to explain that this one you will probably learn in the operating system class. Okay? So we are going to define the record means the one line by line record when we are using the file system. Okay? So this the line by line, each record means one line, and the one data will be stored. Then each one has there are two types, as we have learned in the relational model, two types of the character. One is variable character. Another one is the character, fixed character. Fixed is okay. So we know the name is 35. And the salary, SSN is 10 byte. The salary integer is 4 byte. And job code like that. No problem. We can read. Based on where can you get such information? From here, catalog database. Then we can read the data, fine. However, what if the variable character, like the Smith one is 11, SMITH, comma, JOHN, and space. So it's 11 byte. But if we update the name as John's, we don't know where are they. So because of that, the data, in case of the non-fixed, we should have such a delimiter or separator. So separator usually is the non-frequently, rarely used character. Well, comma is a special case. Comma separate the file, the value CSV is very popular. So what if we have the comma inside? That may be the problem. So we cannot use a CSV for database. But CSV can be used for the non-database, the file structure. So we cannot use such a comma, instead very rarely use the character separator. Okay? Then we can have such a separator or delimiter. The terminator means end of file. So you can use the file to represent the data in the file. Okay? So blocking is later when we talk about this one. Block is a very important concept to understand. Why? Why block is important? The reason why I'm using not only the database management system, but any computer, the software, the main reason to use such the software or computer is efficiency, fast access to data. Then when you judge whether the transaction is fast or slow, or the computer system is fast, my algorithm is fast or slow, how do you judge? How do you judge? You learn
Response.
in your
Response time.
response time. Data structure class. Big O notation, complexity analysis. Second, number of I/O on the memory, right? Then we are going to read this one, 5. So which one is the most expensive operation among them? latency or the complexity, whatever, but reading a data from hard disk drive or SSD is the most expensive. Comparing to other CPU time or the complexity or whatever, the most critical portion of the performance is from the I/O, number of I/O. How to judge it? I/O, number of blocks you read. So because of that, block is very important, the factor or the metric to judge the performance. So we will see a lot, the blocking later. So block will be used. Okay, then each file is you can easily understand the unspanned, the span. So each block is less than the 512 byte. Okay, then we have record size is 100 byte. So each record is 100 byte. 100 byte, 100 byte. So how many records can you keep in our block? Each record is 100 byte. Our block size is 512 byte. How many records?
5.
5 of them. So 1, 2, 3, 4, 5. 12 byte is a remainder. So if you are using the 12 byte and connect to the next block, so this one will be the 88 byte. So it's called the span. If you ignore the remainder and create a new one, it's unspanned. Which one is faster? Spanned or unspanned? Unspanned is definitely faster because span, sometimes you need to read 2 blocks, 2 I/O. As I said, I/O, block, number of block is the metric to judge the performance. Right? If you have only 1 block, it's okay. However, if your system has millions of blocks, 1 million versus 2 million, it's a huge difference. Because of that, anyone who ever used Windows 95 or 2000, old version Windows, you're quite old. It was suggested, do you remember? The disk defragment.
I was 5.
So, you're 5.
I had
Disk the defragment software. Meaning is, because your block is separated along the entire disk. When you read the data, here and there and here, like that, it takes a longer time. Instead, if you compact, this is the same as compact your disk, put together.
They still have that. You still have to run that on all the way up to Windows 10.
Oh, Windows 10 still have that?
Yeah.
Yes, it's not automatic. So this is the same problem. It's the fragmentation issues. So if your file block is fragmented because of the spanned record, so your database will be slow. So this is the kind of the, it's not a funny story. This is one of the reasons why I decided to study abroad, United States. So I was a database administrator before I moved to the United States. Even I worked for one of the banks in Korea and IBM 2 years, so total 7.5 years as a database administrator. I believe that 50–60% of my job was to solve this problem because when you insert, delete, update the data, data will be fragmented, like this problem, span. So how can you solve this problem? It's a simple. Backup, delete, create, upload. Really, this is called the reorganization. Sometimes it's called the reorg. So reorg is a very simple job, and the performance will be sometimes 30%, 40% increase faster. That makes sense, right? If you're the student, this room and other room, it's very hard to find all of them. But if I put all my students in one room, it's faster, right, for communication. But problem is, it takes a long time. That can be doable. Problem is, it should be done at night or holiday. it's mostly the most of system is like the Friday evening or Saturday evening. They have the kind of the time slot for the maintenance. That's when you need such a service. So I couldn't celebrate any holiday, and and if this one is working well, it's okay. But so I can ask the operator to monitor, and that's it. But most of the time, something wrong. So the operator call me, and at 3 a.m., 4 a.m., I should go back to my office and check it. But even in the morning, I should check whether the system is going well or not. So then my life almost killed me, or otherwise the divorce. So that's one of the reasons. So quit my job. But still, I heard that some of the administrators, they're still doing the really caveman style the job.
Even they used to do it manually?
Oh yeah, because it's if you fail. So DBMS, most of the current the commercial DBMS, they support automatic reorganization. But most of the administrators, they do not believe. Because they keep watching, so sometimes you do better, do by yourself. So that's the reason why we have the reorganization or compactization or such a defragmentation. So this is because of the spend and unspent. So finally, we can design. This is one of the example, simplest way to design our data structure for the table. We can use a file. Have you ever seen this kind of operation and the data structure? And the read order and more details of such a database operation. CURD, create, update, read, delete. CURD operation, they are implemented here. And also find or find the next, more details of the searching the data from the file. Which means if you have such an operation for the file, then when you create the file for the table, this operation already inherit. So you don't have to implement it separately, just the core, use the method of this EMP file, then you can search the data. This is one of the simplest way to the design file. But there are different types of file. First, unordered file. Unordered file means this file is not ordered by the key. Which one is better? Ordered file, unordered file. Which one is more popular? Ordered. Unordered is more popular. Why? Unordered file definitely is easy to find and fastest way. Problem? Whenever you insert data, what happens? You need to check the order. Okay? It takes a longer time. So it's overhead. Huge housekeeping. So we are using the mostly unordered file. How can we search the data? Linear search, brute force way. And what is the complexity of the linear search on unordered file? N over 2. Okay? It's N over 2. So it's for example, heap or pile is the example of that. So we can mostly use the file structure for the table. If you have the ordered file, so you need to manage such an order. So, however, this one is very good for searching. We can use binary search. What is the complexity of the binary search? Log n, the base on 2. Okay? Binary search. So, but overhead is huge. Then we can sometimes use a hashed file. What is a hashed file? What is a hash? Hash function. Everybody learned the hash function in your data structure class, right? Let me change the question. Then most of the students can answer. What is the most popular hash function? Hash function. What is the most popular hash function? No one? modular. So this is the most, but there are many. The hash function, so you can use the 128 byte, the hash key, or the 20. But this one is the most popular and simplest one. Let's see why. So hash function is you can make the data, complex data, very simple. Okay? So for example, the modular. So if you have a 0, 1, 2, 3, forever, modular by the 3. 0 goes to 0, 1 goes to 1, 2 goes to 2, 3 goes to 0. Okay, one of this. This is a hash function. Benefit, you can simplify. Whatever the number you have, 10 digit, 20 digit, it will be one of these, 0, 1, 2. Right? Okay, simplify. And also, another important characteristic is it's a one-way. It's not bidirectional, which means once you change it, apply the key, no way to go back. That's the reason hash is used for security. Then, how can we use for the database? When you have data, so using, let's say the hash function is modular by 3. So any data goes to, it's called the bucket. So when you are using the hash for such a data structure, it has a bucket. Hash bucket means any data that goes to 0, stored here. This one, 1. This one goes 2. So when you have data, one of this. So based on hash, so definitely each bucket has number of this data block. So that's the same thing. Then, what is the benefit? If you are searching the data, you can apply same hash function. Lead is 2, for example. Then only search this. So only 1/3 of data, even though linear, 1. If you are using the modular by 5 or 10, it's a 1/10. It's a 10% linear search. By applying just a simple modular function, modular is also implemented in the instruction level, which means the fastest one. So then we can narrow down search area 10%. It's a huge. We didn't do anything, only the hash function. That is the reason still hash file. Hashed file is used a lot, even in the database and the file system to speed up. Without using any buffer management, without using any index, so we can drastically increase the performance of using the hash. However, the last one, for your remind, you learned most of the in your data structure class. Hash, there's a critical problem of the hash. Do you remember?
If we do the change, the hash value changes.
Then it will change it, but the major problem is it's called the collision. If you have like the James, but if they have the same hash value, goes to the same. We need to anyway linear search inside. Hash collision. It's a collision in the hash. There are several ways to. I'm not going to go for that. In the algorithm class or the data structure class, so hash is simple but very powerful. Not only the indexing, but it can be used for security nowadays. Blockchain is based on the hash. Okay? Blockchain is based on hash, so then database use a lot. So this is the solution of such a collision problem. Open addressing, chaining, and multi-hashing. I'm going to skip this part. Okay? So we can create a file for the table using what? File system. At that time, we can use ordered file, unordered file, hash file, but they should be based on the block. The next class we will continue for the indexing structure. It's much more fun. Okay? Any questions? What time is it? Oh, it's already 10 minutes past. Thank you, and we will see you on Wednesday.